going to take a look at polynomial rational equations and how they operate. Now, question. If I am talking about solving this particular inequality, what am I actually trying to say? What does it mean when we say solve? We got a clue. Possibility. And after all, they tell us to solve, and we go through and do a whole bunch of stuff to do that. But what is it really implying when it says solve? What do I want? Correct. That's just another name for solving it. It's the solution. But what does that mean? What does it imply? What is it asking for? And a lot of times when students are told to go through and solve, they only remember the mechanics. They go through, these are the steps that I have to go through to solve this particular thing. When we are taking a look at this idea of solving, all we are doing is trying to make the equation or inequality true. It's really asking the question, where is this equation or inequality true? So if the inequality here in this case wants us to solve this by graphing, okay? So I've got something here greater than 0. Well, if I've got it graphed out wherever it's bigger than 0, would that not be the solution? So that means the solution here would probably run from, -3 to 1. Remind you that's going to be parenthesis, correct? And this here would be 1 parenthesis, comma, infinity. After all, that's where it is greater than 0. And really all that we want to take a look at is just simply this part of it and then evaluate it according to some rule. Now I could have that rule over there, but if I had that thing set greater than 6, would have that been a valid question to ask? Where is this greater than 6? Would it be easy to figure out according to the graph? Maybe. Would I want to put some values in there that might get us close to 6? See, this is where if we drew the line across through here at 6, I know it would have to hit here, and have to hit over here someplace, right? So I would just simply have to figure out where in the world those things are. Could have I figured out where this thing is bigger than -3? Yeah, because -3 turns out to be down here, and it would be whatever going up here. So that's all that we're looking at. That's all that we are thinking about. So how do I solve it algebraically? Well, algebraically is a lot easier, because algebraically, if we set something equal to 0, we know how to go through and solve for something equal to 0. Now, in this case, we're dealing with an inequality. Well, I'd have to go and factor this thing, or move that x over here. Well, gee, I factor out the x, so now I see this. Do you know how to find the zeros? Where is x equal to 0? Where is x cubed minus 1 equal to 0? Now I will tell you this. This is a third power. That's a third power. And you're going, what? It is. And I think I had you write down whenever you've got a difference of cubes or a sum of cubes, how it factors out. Did I not point that out to you and have you identify that? have it in your notes somewhere. I'll go through and reiterate where that's supposed to be at. We factor it out, we find out where it's all equal to 0. Well, it's kind of obvious that if this is going to be equal to 0, it end up just simply having to be 1, right? That would make sense. It's the only way that you could actually get it equal to 0, correct? Because the third root of 1 is just simply 1. But there are ways of factoring it out to don't figure out what's going to happen. So, that's where we get to this table. And this is where the table actually comes in extremely handy. What we are looking for here is, where is this bigger? Where is it bigger than 0? Where is it going to be this? Well, if I am at 0, is it above it or below it? If I pick a value that is less than 0, what do I get? What kind of a value do I get? Well, I pop it in here, do the math, and I end up seeing that, hey, it's 2, it's positive. So would that imply that everything that is on that side, should that be above or below? It would have to be above. Why? Because we know that at these particular points it's equal to 0. Because we know that the behavior of a graph has to be stated within certain parameters, okay? The only way for it to go across or hit that 0 is for it to either cross it or touch it. Those are the only two ways that it can happen, mathematically speaking. So, I take a look in between 0 and 1. What is it doing? I pick a value, I get a number. Ooh, look at this. Turns out to be negative. So does that mean it crosses here? It crosses. It's above it here, below it here, and it's got to be here again. So I've got two possibilities again. It either is going to cross it, or it's going to touch it, bounce down again. So you pick a number on the other side of it. That's where they picked the 2. They did some math and they ended up getting 14. Well, hey, that's above it. So I've got a picture in my mind now of what this graph looks like. We identify its zeros and we kind of know where it's going. We know it's going to be above. We know where it's going to be below. And if we are dealing with an inequality, like what we are here, we're just looking for where that actually happens. Where is x to the 4th actually larger than x? And it would appear that it's going to be any number that we pick that's less than 0, and any number that we pick that is larger than 1. So, if I asked you to solve a rational inequality using its graph, so I want you to solve x minus 1 over x squared minus 4. Where is that greater than or equal to 0? Well, what do we know? Well, we know that we got a denominator in here, and we got x squared minus 4. When you see that pattern, did it automatically factor it in your head? Difference of 2 squares. X plus 2, x minus 2. So that tells me that my zeros are going to be at 2 and negative 2. Did you see that right away in your head? Did your mind go and look at that denominator? Hey, where is this thing 0? Now, mind you, I am talking here in very, very, very general terms. In a lot of instances, it's kind of like a diagnostic on something that didn't work, didn't run. Over Christmas break, I ended up getting a different vehicle for my son. Not a problem. And drove it around, and all of a sudden, about a day later, check engine light came on, started running rough. Gee, what do I do? I need to find the solution to this particular problem. What are the ways that I can do that? Well, I happen to have a code reader, so I can plug it into the car, and it can tell me what the code is. I see the code is, I know what to do with the code is, the coil pack. I'm getting a misfire on a particular cylinder, and okay, fine. It was kind of wet and dampish out down in the cities, so okay, fine. Replace the coil pack, runs fine. 24 hours later, another coil pack fails. Now I just got, whoa, hold it a second. I already seen that one of the coil packs. What's the deal? Do I have to do more digging? Do I have to do a little bit more research? I do. I find that the epoxy that they put on top of the coil packs has a tendency of cracking, and then if it's dampish out, it ends up seeping through there and can create a short. All three of these coil packs that I noticed that had to be changed were on the front side of the engine. Okay, fine. The three that are in the back are probably going to be fine. They're a little bit more hidden, protected. Solved. Yes. All I did was use some very general ideas on how to go through and solve the problem. You know how to go through and graph a particular inequality like this. You know, the x minus 1 over the x squared minus 4. You've done that. You know where to go and look at the zeros. Hey, those are the critical points. Do I really worry this time about asymptotes? Not really. Because they're either going to be above or they're going to be below. When I'm talking horizontal and the oblique ones, mind you. The zeros are going to be the ones we have to worry about. So, can I look at this graph? Can I run a set of test points? Can I go and identify where I need to be? Yep. A lot of it is nothing overly complicated. It is just simply the process of how do I solve it. Look for the zeros. Find the zeros. Once I've got the zeros, can I plug in some test points on either side of them? Yep. And then I can get a ballpark idea of where things are going. Now, when you're doing test points, I will tell you this much. I've got a gap that's going on like this. We know a few things about the pattern of this particular kind of graph. Check numbers that are close to each asymptote. We know that there's also going to be a 0 here at positive 1. So it's got to cross there. And I know that negative 2 is on this side of 1, positive 2 is on that side of the 1. So I got a ballpark idea that it's got to cross somewhere in this gap, right? I don't care where. I just know it's got to happen. Which way is it going? Again, the points will give you an idea. Is it a plot? So, how do I solve that algebraically? Set it equal to 0. Okay. Now, I will talk about a catch right here. X plus 2 over x plus 2. Why in God's name would I want to do that? So I'm going to kind of walk through that one a little bit more so you get the idea of why I want to do that. So, I'm starting off with 4x plus 5 over x plus 2. We bring over the 3 greater than or equal to 0. If I am going to deal with this in terms of fractions, do I have to have a common denominator? And the answer is yes. So what is the denominator that I must have in order to deal with this? Well, that's where it's got to be this x plus 2 here. So if I go and take 4x plus 5, x plus 2 minus 3, I am going to need to have something with a denominator of x plus 2 down here. But I just can't arbitrarily go through and multiply by a value, can I? Is there a value that comes in really handy for just multiplying through so I can change how it looks but not actually change the value? Is there a number that exists that if I multiply through by it, it doesn't change it? Darn blasted thing when it comes to value. So if I go and make this x plus 2, what do I end up having? Same thing on top, same thing on the bottom, is just what? So now that I got that, I got my 4x plus 5 minus 3x minus 6 all over x plus 2. Can I go through and deal with that? Most definitely. Let's see, if I add like terms there, I end up with x minus, minus 1, right? 4x minus 3x is an x. 5 minus 6 is 1 over x plus 2. Do I know some things? Yeah. I have a 0 at x equal 1, correct? X cannot be equal to negative 2. This is correct. So already I kind of know some things. Right there. 0 at x cannot be negative 2. So the question is here, where is this thing greater than or equal to 0? Where would it be? Continue on with this so we get this combined like terms. And you're going to kind of look at this and say, well, gee, what's the deal? So we look here, negative 2 and 1. We got that wonderful chart again, right? So I know where things can and cannot be. I know that here they're positive, here they're negative, here they're positive. What was the question? Where is this thing greater than or equal to 3, or in this case, greater than or equal to 0? So where is it bigger than 0? If it's less than negative 2, positive 0. It's bigger than 0 when it's greater than 1. Nothing super specific, is it? Look at the zeros. Look at the points of discontinuity, where your denominator can't be equal to 0. Those are your guides. So when I take a look at this, they go through these steps here. Write the inequality so that 0 is on one side. We have ways of dealing with 0. That's why it's such a fun thing to do. Okay. Set it equal to 0, less than 0, greater than 0. Because then we know our denominator has certain things that can not happen. Determine the real numbers at which the expression equals 0. And if the expression is rational, the real numbers where the expression is undefined. Where 0 can't be in the denominator. Use the numbers, divide it up into a chart. What number line? Select numbers in each interval and evaluate. That's all it is. It's just a set of rules to follow as a diagnostic expression. And in reality, that's what a lot of things are. How do I solve something? How do I figure it out? There's a set of rules to go and answer that particular question. So I'm going to let you guys get to work on this.